Reflections. These are big ones. Reflections are ones that you probably really need to understand because it has to do with the symmetry of the graph and how it's reflected when you have a negative inside, when you want to make it the opposite of. So when you have a negative outside the function, so the entire function is the opposite of whatever the original function was. Then it's reflected across the x-axis because all of the y values have been made negative in this case. The x values stay the same. It's the y values that are made negative. The other way, the graph is reflected around the y-axis when you put negatives on the x values. Again, just the x values get negative. Nothing else, just the x values. So if it had a constant in there, it still stayed positive. But if the x values, all of the x values are made negative inside the functions, its graph is reflected around the y-axis because all of the x values of the point are made negative. All right, so some pictures here. The first example here is the reflected about the x-axis case, right? Here's the original function. So it would be a parabola that was opening up. And then what we did is we took the negative of it, the opposite of it. All of the y values on these function became negative. The x values stayed exactly the same. It's the y values that became negative, and so the entire function is shaped exactly the same. The shape doesn't change. It's just flipped over the x-axis. Right, the other direction, the y-axis flip, is when we take all of the x values and make them negative, and that's when it's reflected about the x-axis, or sorry, the y-axis. X values are made negative. So again, I would have had a point here. That would have been x, y, and then it gets reflected over here, negative x, y, and so all of the x values are made negative. All of the y values stay the same. It's reflected over the y-axis in that case. So again, it's flipped over the y-axis. The shapes are exactly the same. It's just been reflected over my axis. So I'm going to do a couple of examples. And again, you always plot at least 3 key points whenever you're graphing anything where you're doing transformations. 3 key points is always what we use. And key points meaning if it's a parabola, you've got the vertex and a point on each side. Right? So key points, that's what we mean by key points. Right, this time, though, I'm doing the square root function. And so the original function, the original square root, the 3 key points I'm going to use are where it starts, right? 0, 0. Plug 0 in, you get 0 out. 1, 1 is always a good one. 1, 1. Right? And then 4, 2. So 1, 1, 4, 2. And then remember, it's got a slight curve to it. It's a parabola. It's kind of half a parabola is opening to the left. So there is f of x, which is the square root of x function. Alright, and then what we're doing to get g of x, and I'm actually going to draw it over here separately since I didn't give myself a whole lot of room to do so there. Alright, and so to get g of x, well, it's taking all of my function values and multiplying them by a negative, right? Negative square root of x. And so all of the y values get multiplied by a negative. All the y values get multiplied by a negative 1. And so 0, 0 is still 0, 0, right? 0 multiplied by 0 is still 0. 1, 1, though, becomes negative 1, or 1, negative 1. 1, negative 1, the y value changes. And 4, 2 becomes 4, negative 2. Right? 4, negative 2. And then it's this graph down here. So it would have been reflected about the x-axis. And so it's down there, all of the y values. So it's the exact same shape. It's just been flipped over the x-axis. Right? And so that's the x-axis case. Alright, now the y-axis case. So same function, still square root of x. I'm going to start with the same exact one. Actually, maybe this one I will graph together since I didn't done the last one. Alright, so the original function, the 3 key points I'm going to use are 1, 1, 0, 0, and 4, 2, right? Those are the key points I'm using in my graph. So there's my original f of x, which is the x negative inside, negative on the x term. And so 4, 2, 1, 1, and 0, 0 were my original points. And then when we want the new function, all of the x values get multiplied by a negative. So it reflects over my y-axis, right? It reflects this way. All of the x values get multiplied by -1. It should make sense. In order for the function to work, since there's a negative on the x, I have to plug negative values in, right? If I plug 1 in, it's an imaginary number. But if I plug -1 in, I get the negatives to cancel each other out, and now it becomes a +1. And so 0, 0 is still 0, because negative of 0 is still 0, so it still starts here at 0, 0. But then it's flipped over here and becomes -1, 1. And then instead of +4, it's a -4 that gives me out my 2. Alright, my -4, 2. Check it out, plug it in, that is the case. Starts at 0, 0, and so again, there's the shape. That was my original function. This is the h of x, which is negative square root of negative x. And there they are. It's reflected over the y-axis. All of the, and again, it's literal in this case. All of my x values got multiplied by negative, and so that's what you do. Take all of your x values and multiply by negative. When you do that, it's reflected about the x-axis.